What's up, YouTube? It's time we had a talk about null. Null pointers have been called the billion-dollar mistake, and it's easy to see why. If you're coding something important, let's say a financial application, and someone goes to complete a transaction with your application, the importance of that transaction's success cannot be understated. Someone may be depositing money into their bank account or paying a crucial bill. Their balance must be correct. The amount they request or transfer must be correct. The transaction must complete perfectly and without a hitch in order to retain the user and provide a good service. An error could mean bankrupting someone, and obviously that's the worst case scenario, but nonetheless it's important that our code run without issue. What happens when the transaction amount is missing? What happens when the application fails to retrieve the user's balance? What happens when the inevitable occurs and some critical piece of data is just not readily available? Does the application crash? Does it misbehave? And if so, how? When and how we can answer those questions prior to shipping our application is important, and that brings us to null safety. Just what is null safety? There are several newer languages that have come about in recent years offering sound null safety. One such language is the Dart language, which powers Google's relatively new Flutter framework for cross-platform development. Null safety means, in Dart, that at compile time, if there is any code in your project whatsoever that might throw a null pointer exception, that code will not compile, allowing us to catch these null issues at build time instead of in production. In short, Dart forces you to consider the possibility of null anywhere that it could exist in your code, and in doing so, it prevents a whole class of exceptions that plague applications at runtime today. If you've ever spent a day trying to figure out why something is undefined in a JavaScript console log, then you know exactly what I'm talking about. When I first started using Dart, I will admit I hated the extra steps required to be null safe. But as my projects grew and the complexity of my applications went up, I found myself incredibly grateful for the null safety features. These features, once I got used to them, helped me to write better quality code, and I found myself stopping less often to track down bugs, and thus spending more time doing meaningful development. Nowadays, I regard null safety as one of the 3 requirements I look for in a programming language before ever deciding to jump in and try it out. So, let's see null safety in action. Alright, we're going to go off script here for a second, so I apologize for the ums and ahs, but I've taken the default Flutter application and modified it really quickly just to demonstrate null safety here, and I think that this is a good visualization. You don't necessarily have to be creating a Flutter application in order to take advantage of Dart or Dart null safety. The language can be used for other things, but I think this is a good visualization, so this is what we have. Over here on the left, I've created a quick transaction class and put a static method on it to add 2 nullable values together. How do I know that they're nullable? Well, in Dart, every type has a companion type, and the companion type is nullable. When you create new objects and define new classes, even your classes have a companion type created under the hood for you. And what does that companion type look like? Well, that is the question mark here at the end of this int declaration. So when we have an int, this is a not null int. It can never be null. However, if we want a nullable int, we can throw a question mark after it, and now we've said this can take a nullable int. And so this addition method takes 2 nullable ints. And you can see that in order to get our application to compile, when we take in these nullable ints, we have to return something. We have to do something in the event that either of these is null. And we also have to add in null checks. If I were to remove this exception, you can see that now our code will not compile. And if I were to stop this and try to run it again, you can see the application fails to start. So let's bring back that check. We're going to hit Control / to do a hot reload. And the application will have to start completely again because it was actually not running. So now we'll wait on that. Now, what would happen in a typical application when a null value was provided here? So let's try first without null values just to see what happens. And you can see that the two values are added together. And then if we take one of these away, we should see an exception thrown here in our console. Now this isn't great. This is runtime exceptions, and this is exactly what we're trying to avoid. So how can we rewrite this to take advantage of Dart null safety? Well, we could get rid of our exception here, and instead of taking nullable ints, we could say we only want not null ints. And now you can see here that these integers cannot be null, and so we can even remove this. And now all we really need to do is add num1 and num2. Heading back over to our main.dart, we can see our code in action here, and we can see num1, num2, and we can see the two things being added together. Assuming that we provide values, everything should be okay. However, if we hot reload here, we can see that this code will not build. And so if I close this and I try to run the application, it will fail, and it'll tell us that there's the potential for this value here and this value here to be null. And because these values could be null when we're trying to parse from our controller on the page, we cannot run them against our transactions add method, because the add method takes only not null values. So how do we deal with this? How do we get our application to build again? Well, it's very simple. We take our nullable values, num1 and num2, and we check them for null. So Dart has forced us to consider that these values could potentially be null, and it makes sense. We're working with a text editing controller here, and this text editing controller allows for user input. The user doesn't have to input any value, and so when we try to parse this value, there's the potential that we're not going to succeed. Maybe there were no checks to make sure that only numerics were provided. In our case, we did check that, and we only allow for an integer number to be provided. However, if we didn't, or if the value was null, this code could fail. And so Dart sees this and says, okay, you can use this, but you have to check. We can now run this again, and because we have checked for null, the code should compile without issue. And as you can see, if we put a null value in to either of these fields, nothing happens. But if we include a value in both of the fields, our state becomes set. Now back on script. As a recap, we learned that with the Dart language, every data type has a nullable companion type. Even classes we define have a nullable companion created under the hood. We learned that we can use this nullable companion type by adding the question mark symbol to the end of our type declarations. By utilizing nullable types only where null is appropriate, and utilizing non-nullable types where a value is a necessity, we can enable Dart to stop null pointers at build time and never again have to catch them at runtime. This improves the overall quality of our code, prevents potentially dangerous operations, and improves overall user experience.